Today we're going to talk about partial fractions. And you might be like, how does that have a connection to systems of equations? We will have to solve a system as we work on basically partial fractions are going to be what we're going to work on doing is taking a fraction and decomposing it. So breaking it up into smaller parts. So an example of this is if we had this rational expression, so 3 divided by x minus 4 minus 2 divided by x plus 2, and we wanted to combine those, well, we'd have to get a common denominator. And after getting a common denominator and adding the fractions, we get to here. So we know how to do this process, okay, going from multiple fractions and adding them into one. But what if we needed to reverse that process and go from one fraction and decompose it into its smaller parts? That's what we're going to work on today. Now, for now, like what we're doing in this class, there's not a whole lot of value for it. The value is going to actually show up when you get to calculus. So for solving the kind of calculus problem described in the section opener, I didn't give you the opener, you are going to have to do this. So this is a big piece of what you will eventually do in calculus. For now, it's basically really good algebra practice and systems of equations practice. Don't worry about writing any of this down because we're going to get to the examples here in just a second. Okay, so again, what we're going to focus on is taking this one fraction and breaking it apart, and so we can write it as a combination or a sum of smaller fractions, thus decomposing it. Each of the two fractions on the right, so the smaller parts are the partial fractions. The sum of the fractions is called the partial fraction decomposition of the rational expression. There are multiple ways in which we need to solve these. So there are 4 different cases. And again, I don't think we need to write these. I'll kind of touch on these as we go. We're going to basically do the first 3 today, or at least it's our goal, but these take time. So the first one we're going to do is where the denominator is a product of distinct linear factors. So let's jump straight into that example. Okay, so partial fraction decomposition with distinct linear factors. So maybe make a note of distinct linear factors and then go ahead and jot down that particular problem. Excuse me. And so the first thing that we're going to do is we're going to actually set up what it's going to look like when we take this apart, when we decompose it. And when we decompose it, we're basically going to take each factor in the denominator and have a unique fraction for that factor. So the numerator is what we need to solve for. So our new numerator for now we're going to call A, and we're going to put it over one of the factors, x minus 4, and then plus, this time we'll put B as the next numerator over x plus 2. So we're just basically breaking up the fraction based on how many factors there are in the denominator. And now our task is to solve for A and B. Yeah, no, go ahead. Always go with adding. The sign will take care of it within the work that we're going to do. Okay, I had that same question earlier today, and I'm like 95% confident that it's just always adding. And if it's negative, it'll show up in the work. Okay? All right, so how we're going to solve this is actually how we have solved rational expressions in the past, where we're going to basically work to get rid of all of the denominators. So what I'm going to do right now is I'm going to take this whole equation and I'm going to make the left side, we want the factors to go away. So basically we multiply by all factors so that way we don't have any more new denominators. So I'm going to take x minus 4 and x plus 2, and I'm going to distribute that to every single term on both sides of the equation. This first time around, I'm going to show this distribution. It's going to look really messy, but a lot of things will divide out. And so as I do the other examples, I'll just do that dividing out in the first step to make it look a little bit nicer. So when I distribute, we have x plus 14, and we're giving it an x minus 4 and an x plus 2. And it's still over that same denominator, x minus 4, x plus 2. On the right side, we have a times x minus 4 times x plus 2 divided by x minus 4, and then plus b times x minus 4 times x plus 2, and then all over x plus 2. And again, the reason we did this is because now all of these denominators will go away, giving us x plus 14 equals a times x plus 2 plus b times x minus 4. So we've got rid of the rational part. Okay, it's not rational anymore. I guess technically it's linear. And we have three variables technically, x and then a and b. Well, really we're trying to pin down what a and b are. And we know that a and b, well, if we think about what we want a and b to equal, we want a plus b, or these a and b values, to somehow be equal to this x plus 14. So this x plus 14, we're going to leave as is. And what we're going to do is we're going to distribute this a as well as this b. So I have x plus 14 equals ax plus 2a plus bx minus 4b. Next thing I'm going to do is just rearrange the terms so I have the x's next to each other. So x plus 14 equals ax plus bx plus 2a minus 4b. One thing that I'm noticing here is within these first two terms, ax plus bx, they have a common factor of x. So I'm going to take out the x. So I get a plus b times x, and then plus 2a minus 4b. And so now, this is where the system of equations is going to come into play. And what we've done is we've got this left side of x plus 14, and we want the right side to somehow match up with that. And so if I look at, well, I'd see this x in both places here. So basically, we need a plus b to equal whatever the coefficient is in front of x. What is the coefficient in front of that x there? 1. So we need a plus b to equal 1. And then the last part is we need this 2a minus 4b to equal this 14. Okay, if those things are equal, well, now we are going to be able to find the values of a and b from that. So then 2a minus 4b equals 14. Once we have the values of a and b, we can replace them in our partial fractions, which is the decomposition. I'm going to pause right there. Is everyone kind of seeing where I'm getting this system from? Okay, and how the a plus b corresponds to the 1, and how the 2a minus 4b corresponds to 14. All good here? Okay. Got a question over there? Okay. So now we just got to solve this. We can solve it with any method we want. Substitution would be easy. I can subtract b. I still prefer elimination, so I'm going to take the top equation, multiply it by negative 2. So I get negative 2a minus 2b equals negative 2. I'm going to add these bottom two equations where the a's eliminate. And I get negative 6b equals 12, making b equal to negative 2. And if b is negative 2, a needs to be 3 in order for them to add to 1. So now that I have the values of a and b, we can now write our partial fraction. So the original equation, x plus 14 divided by x minus 4, x plus 2 equals 3 divided by x minus 4, and then plus negative 2 divided by x plus 2. Okay, and this actually answers Noah's question from earlier. Hey, do we know if it's plus or minus? Well, when it's positive, well, since I have this plus the minus, it's actually going to turn it to negative. So that's what I mean by it'll get caught up, or we'll see that in the actual work we do. So another way to write this would be 3 divided by x minus 4 minus 2 divided by x plus 2. So either one of these work. They're the exact same. So like I said, a lot of algebra, a lot of steps. Keeping your work organized is going to be really important here. And this is the most basic of all the examples. So it's only going to get more work involved. Okay. One thing I just want to point out, I don't want to take the time to have you write down all these steps, but this will get posted. So like as you're working on Math Excel, or if at a later time you want to add these into your notes, here are all the things we did to work on doing the fraction decomposition. Again, I don't want you to write these down right now, but these are all the steps we did in written out, so you can check that or have that open as you're doing your own work. Okay, well, let's have you all work through checkpoint 1 and just do the exact same thing. Find the partial fraction decomposition of the following rational expression. All right, I'll give you a little bit of time to work through that. So like 4 to 5 minutes or so, and I'll work it out as well. Like the biggest point of confusion was setting up the systems. And with any of the work that takes a lot of steps, I kind of talked about this when we did the systems with 3 variables. Take your time, double check your work. Make sure you write things down correctly, because it'd be really frustrating to get all the way down here and then be like, oh, something's off, and have to redo the whole problem all over again. Okay. Now, one thing that I am going to do from here on out, when I go to multiply to get rid of the denominators, I'm not going to write that out every time. Okay. That just is too much writing. So I know that when I distribute x minus 3 and x plus 4 to all these fractions, it's going to go away in this first, or the left side of the equation. The x minus 3s will cancel out where the a is, so it's a times x plus 4. And then with the b's, the x plus 4s will cancel out, so we'll get that x minus 3. All right, and then the other point of confusion is right here when I set up the system. So because a plus b has that x, where it's the coefficient in front of x, we need a plus b to match up with the coefficient in front of the x on the left side, which is 5. And the right side, or the other term, the constant -1, needs to be equal to that 4a minus 3b. How you solve the system should not matter. We each could have done elimination a little bit differently. Regardless, if all your algebra checks out, it should end up being the exact same. Okay, well, let's step it up a notch. Just a little bit. And let's work on the next type of decomposition. And so let's also write this title. It's with a repeated linear factor, meaning we have this x minus 3 squared. So when this happens, okay, we are going to make a note of this. This linear factor occurs twice. And because it occurs twice, we must include one fraction, and by the fraction I'm meaning the partial fraction. So one fraction with a constant numerator for each power. Okay, so what is that saying? Well, if I take this x minus 18 and I have x times x minus 3 squared, we need to have a fraction for every power of this repeated fraction. So we're going to have a fraction that has just x minus 3. We're going to have another one that has x minus 3 squared. Okay, so we're going to first go a over just the first factor being x plus b over the smallest power of x minus 3 squared, which is x minus 3, plus c, and then the next factor we're just going to increase by a power and call it x minus 3 squared. So that's what this is referring to. We need a fraction with each power of that repeated fraction. So had this to have been cubed, let's say this was x minus 3 cubed, we'd have x minus 3 squared, and we'd have to add another, so plus d over x minus 3 cubed. Okay, if it was a fourth, we'd have to have a plus e over x minus 3 to the fourth. And at that point, we would actually need a matrix to solve this. We don't really have a way to solve this. But this one we are going to be able to solve. And we're going to solve it the exact same way as how we did it before. So now our task is the same as before, where we're going to distribute these factors to every single term. So once we distribute, this entire denominator goes away. So the left side is just x minus 18. The right side, the x's are going to cancel out, so I'm going to get a times x minus 3 squared. In the next fraction, I'm going to get one of the x minus 3's to cancel out. The x doesn't have anything to cancel out with. And then we have one more of those x minus 3's left over. And then over here, all of the x minus 3 squareds cancel out, so we're left with just cx. And any questions up to this point? Because now we got a lot of simplifying we do before we jump into the system.
So why is it that C has x minus 3 squared if it's all like separated out?
Yeah, so I'll be completely honest. I do not know why these play out the way that they do. But anytime we have this repeated linear factor, that's what this note was that we were making here, that we need a fraction with each power of that repeated factor. So that's why it's 1x minus 3 and then another x minus 3 squared. And like I said, had it have been cubed, then we'd have to say plus d with an x minus 3 cubed as well. If it was to the fourth, then we'd add another one onto that. Okay. Again, I don't know the full reasons why we need it this way. It'll work out though. All right. So now the first thing, we need to simplify all of this. We need to get all of the A's and X or A's and B's distributed and C's before we can start to set up our system. So I'm going to figure out x minus 3 squared. That would be a foiling problem, which is x squared minus 6x plus 9. This bx I'm going to distribute, so that becomes plus bx squared minus 3bx plus cx. Then we'll distribute this a, so x minus 18 equals ax squared minus 6ax plus 9a, and then plus bx squared minus 3bx plus cx. Yuck. We can already tell we have 3 variables we're solving for, a, b, and c, so it's going to be a system with 3 variables. Actually, once we get there, it'll be kind of nice. So I'm going to do 2 things here. I'm noticing on the right side that I have these a and b values in front of an x squared term. Well, there's no x squared on the left side. So I'm going to add in an x squared, but it needs to stay the same. So I'm just going to add in a 0x squared. This is going to help me set up my system to allow us to start to find a, b, and c. So 0x squared plus x minus 18. On the right side, I'm going to arrange the terms. So I have my squared terms first, then the x's second, and then the constants last. So ax squared plus bx squared, and then minus 6ax minus 3bx plus cx, and then the last term that is just the constant is plus 9a. Now we have some factoring to do here. So 0x squared plus x minus 18 equals, I'm going to factor out the x squared. So this is a plus b times x squared all three of these terms have an x, so I'm going to factor out that x. So I'm going to say plus, just so I don't have to think about any sign switching here, so plus negative 6a minus 3b plus c, and then the x that got factored out, and then plus 9a. And so now a plus b is going to be equal to the coefficient in front of the x squared, which is 0. Negative 6a minus 3b plus c is going to be equal to the coefficient in front of the x, so equal to 1. And then 9a is going to be equal to the constant, which is negative 18. Making our systems a plus b equals 0, negative 6a minus 3b plus c equals 1, and then 9a equals negative 18. And so now we're going to look to find a, b, and c, which is actually going to go a lot quicker than when we did any of the systems with 3 variables. And that's because I can solve a really easily from this third equation, right? 9a equals negative 18 means that a is just negative 2 after I divide. If a is negative 2, that makes b positive 2. Negative 2 plus 2 is 0. And then we can find c by plugging these into that middle equation. So let's find c by letting negative 6 times negative 2 minus 3 times 2 plus c equal to 1. So that's 12 minus 6 plus c equals 1. So 6 plus c equals 1, making c negative 5. And so our final equation of the decomposition is a, so negative 2 divided by x, plus b, which is 2 divided by x minus 3, and then minus 5 over x minus 3 squared. And we're going to get to one that has even more steps than that. Not today, though. Okay. I think I have one. Yeah, let's have you all do one. And then after that, whatever time we have left will be some Math Excel time. What? Yes. And I have it due on Sunday because we're going to finish this on Thursday. So it's not due till Sunday. All right. Your turn. Checkpoint 2. Last thing we'll do all together. Work through checkpoint 2. Get the same answer as everybody in your group. And we'll go over it. Up on the board. If you have questions about any of the steps I took, let me know. But at least you can check to make sure you got this all right. Your coefficients end up being a of 2, b of negative 2, and then c ends up being 3. And yeah. We have a couple more examples that we'll work through on Thursday. And again, the Math Excel for this is due on Sunday since we have some more work to do. But you can start the Math Excel. Most of the questions are going to take some time. With us having 10 minutes, let's get some work done. I'll be quiet. If you need help with anything, let me know.